Chapter 8, Part 3, we are looking at special cases of quadratic expressions. And we're looking at number 27. And it says, what if you are missing a term? Or what if the terms are in a different order? We're going to consider these while we factor the expressions below. We're going to start by looking at 27a, which is 9x squared minus 4. We want to see what is our GCF, the greatest common factor. So I'm just going to do a little factor tree here. My 9x squared is going to factor out to 3 times x. My 4 will factor out to 2 times 2. We do not have any greatest common factor other than a 1. So we are going to start by doing a diamond and a rectangle. Now, when you look at the 9x squared minus 4, we could rewrite this as 9x squared plus 0x minus 4. So I'm going to set up my rectangle and my diamond, which looks like a triangle. Or I'm sorry, big X. And we're going to start the same way. The first term always goes in the bottom left corner. The last term is going to go in the top right corner. They get multiplied, the two of them, to get the top of the diamond. And then the middle term always goes on the bottom of the diamond. So we want to think what two numbers multiply to give us negative 36x squared, but add to give us 0x. And that is going to be 6 and negative 6. So we can plug them into the two empty spaces in our rectangle. And now we want to find the dimensions, find the bottom and the side of our rectangle. So we're going to look for our greatest common factor for this first column here. And, we could write it out. We could say we have 6x and 9x squared. We could do a factor tree if you wanted. So 6 would be reduced to 2 times 3 times x. 9 is 3 times 3, and then we have our x squared. Our greatest common factor, so they both have a 3, and they both have an x. So the greatest common factor, GCF, would be 3x. So 3x would go at the bottom. And then we can work our way backwards, solving this puzzle. So we want to think, okay, what are we going to put here that multiplies with 3x to get 9x squared? Well, that's going to be another 3x. Then we can think, okay, what's going to go here? What times 3x gives us negative 6x? That's going to be a negative 2. And then the last part, okay, what here times 3x is 6x? That's going to be a positive 2. So when we go to factor this out, we're going to have 3x plus 2 times 3x minus 2. In part B, we have 12x squared minus 16x, and I started by doing the GCF, and we have a 2 in common, another 2, and an x. So the GCF is going to be 4x. So we can take out 4x from our expression. So I'm going to set this up with a 4x on the outside of my rectangle and my 12x squared minus 16x inside the rectangle. So now we want to find out, okay, what's going to be either on the top, or I guess you could do it on the bottom as well. What's going to go on the bottom of this rectangle so that you can multiply them to get 12x squared minus 16x. So by working backwards, so what times 4x gives us 12x squared? Well, that's going to be a 3x. What times 4x is negative 16x squared? Well, that's going to be a negative 4. So our factored form is going to be 4x, and then in parentheses, 3x minus 4. Okay, part C, 40 minus 100m. So we don't have a quadratic expression. We don't have an m squared. So we are going to start by trying to find the GCF, which I already broke down. So 40 is 2 times 2 times 2 times 5. 100m is going to factor down to 2 times 2 times 5 times 5 times m. So I'm going to circle what's the same. So they both have a 2, both have another 2, both have a 5 in common. So our GCF is going to be 2 times 2 times 5, which is 4 times 5, which is going to give us 20. So I'm going to set up a rectangle with 40 minus 100m inside and my 20 on the outside. So we want to find out what's going to be on the bottom, so when we multiply by 20, we get 40 minus 100m. So if I work backwards, what can I multiply with 20 to get 40? Well, that's just going to be a 2. This becomes 2. And then what can I multiply here with 20 to get 100m? Well, that's going to be a negative 5m. So when we factor 40 minus 100m, we'll take out a 20, and we'll have 2 minus 5m left over. In part D, we have 8k squared minus 10k plus 3. And I already did little factor trees for them and broke them down to see if there's a GCF. And there isn't one that they have in common besides the number 1. So they don't really all have anything in common. So we are going to get started by doing the generic rectangle and the diamond. So my first term is going to go down in the bottom left. Last term goes in the top right. We multiply them to get 24k squared in the top of the diamond. And then the middle term is always the bottom of the diamond. So we need two numbers that multiply to give us positive 24, but when we add them, we get negative 10. So we need to think what combination would work out, and negative 6k and negative 4k would do the job. So we can plug them in, and it does not matter where you put them in the rectangle. And now we want to find out the GCF, or the greatest common factor, of the first column. That way we can find out the dimensions of the bottom and the side of the rectangle. So I'm going to focus on the first column here, and we have negative 6k and 8k squared. So if I break down my negative 6k and 8k squared, 6 is going to be 2 times 3 times k, and then 2 times 2 times 2 times k times k. So they both have a 2 in common, and they both have a k in common. So my GCF is going to be 2k. And then we can work backwards. What here would multiply with 2k to get 8k squared? Well, that's going to be a 4k. So then here, what times 4k is negative 4k? Well, that's going to be a minus 1. And then what here times 2k is negative 6k? Well, that's going to be a negative 3. And then you can check negative 1 and negative 3 make a positive 3. So our factored form is going to be 4k minus 3 times 2k minus 1. And these parentheses could be flip-flopped. You could have the 2k minus 1 first and the 4k minus 3 second. It does not matter. The next problem we're going to look at is number 28. And we are going to try to do the GCF first. And after practice, you might get the hang of this, that you don't have to do the factor trees, but we're going to start with that right now. So if I factor it out, that's going to be 2 times 2 times x, so 4x squared. My 10, that's going to be 2 times 5 times x. And then my 6 is just 2 times 3. So if I look at my factors, all of them have a 2 in common, and that is it. So the GCF is 2. So that means I can pull a 2 out of my 4x squared minus 10x minus 6. And you might be looking at that and say, well, yeah, I can just take a 2 out because they're all divisible by 2. So that will leave us with a 2x squared minus 5x minus 3 left over. So we have 2 times 2x squared minus 5x minus 3. Now we want to make sure that this is totally factored out. So we are going to take this part here and see if we can do a diamond in a rectangle. See if we can factor it out any further. So we'll have 2x squared in the bottom left, negative 3 in the top right. That multiplies to give us negative 6x squared in the top of the diamond. Negative 5x is in the bottom of the diamond. So we need two numbers that multiply to give us negative 6, but add to give us negative 5. So that's negative 6x and positive 1x. So when we plug them in, it does not matter which spot they go in. We want to find the GCF of that first column. So negative 6x and 2x squared, the greatest common factor is going to be a 2x. And then we can work backwards to find the other missing pieces. So our true factored form is going to be 2 outside a parenthesis of x minus 3 and 2x plus 1. So this is factored completely. We can't break it down any further.